Hi everyone, my name is Thomas Kim. Today is June 5th, 2019. This is my 29th episode about the future of C++ programming, C++ 2A standard. In this episode, we will implement shared PTR, Weakptr from scratch. Disclaimer: the following implementation for shared PTR and Weakptr are my own work. These are far from perfect and can have flaws and bugs. Do not use these implementation for your production level development. These are for educational purpose only to help my audience better understand C++ standard libraries, shared PTR and Weakptr. You can refer to shared PTR by clicking this link. In this episode, from time to time, we will refer to this documentation and we will not implement all, but we will implement enough tools for shared PTR. The primary reason I decided to film about shared PTR is that STD atomic, STD shared PTR, this type will be introduced to C++ 20 standard, and this class will be indispensable tool for any serious C++ multithreading. To follow this episode, you require quite a lot of information about C++. We will basically use move semantic, copy Elison, type trace, especially std enable if t, and dynamic memory allocation, template metaprogramming, and explicit, noexcept, etc. I will try to make it as simple as possible, but it should be as detailed as possible as to properly depict how std shared PTR and how std weak PTR are implemented in C++ standard library. For reference videos, C++ template metaprogramming, this series of video, I made 45 videos. If you want to watch, please double click this link. Also, C++ type functions, modern C++ programming. In this episode, I dealt with type functions, especially about type list, 30 videos about C++ concepts. These are for general C++ concepts. Up to this point, 74 videos. And this series is Future of C++ Programming. Up to this point, I created 28 videos. And this is episode 28 about cyclic references and shared PTR Weakptr. From this episode, we have to download some source code. From this video, click Show More. Click this button to download our previous source code. Show in folder. Unzip the downloaded file. Rename the solution. Change it to O4. Cut the solution. Cut. Paste it to your working directory. Double-click the folder path. Copy the folder path. Copy. Ctrl-C. Start Visual Studio. I'm using Visual Studio 2019. Go to File. Open. Project Solution. Paste the folder path. Hit Enter. Select this solution. Memory leak detection solution. Click Open. If Solution Explorer is not displayed, click this button. Click this button. Right-click Solution. Add a new project. C++. Windows. Console app. Next. Shared PTR O4 create. Right click, set as startup project. Right click once again, properties, make sure all configuration, all platform selected. Click C++, additional include, edit, click this button, solution, dir, include, click OK, language, C++ 17, click OK. Right click, add existing item, go up, include memory leak detect. Right click, new item, header file, shared ptr.h, add. So we basically have one CPP file and one shared PTR file. Click this button. I will drag it. Remove this part. Include shared PTR. Include memory leak detect. In shared PTR, include IO stream, include type trace for std is same b std is class b std enable if t. We don't need this. I will also add a string. String include exceptions. Namespace talk play fun. End of namespace talk play fun. We will try to make it as simple as possible. Struct representation base size t and Usecount size t and Weakptr. So I will change it. Manage count. I will change like this. Manage count size t uses 0 size t weeks 0 and use count uses and weak count weeks. So this is default constructor. Struct representation base. It has two pointer. It should be template. Type name element type. Element type, this is pointer m. Element ptr, we will be using manage count m count ptr. I will create simple constructor. Element type ele ptr null ptr manage count ptr null ptr m element ptr ele ptr m count ptr So we created two struct manage count. It is used for manage use count and weak count. Representation, I would just say representation. Representation has two pointer, element ptr and count ptr. Template, type name, element type, class, shared ptr, end of class shared ptr. Template, type name, element type, class Weakptr, end of class Weakptr. It should inherit. We are inheriting from representation element type. We also need to inherit copy like this, and we need forward declaration. Forward declaration for Weakptr. Now here print template, type name, type, print, class Weakptr. Template, type name, type, print, class shared ptr. We need to declare This is shared PTR. This is weak PTR. Both shared PTR and weak PTR inherited from representation from this class. Private, public, we will also create an exception class like this class bad shared PTR. We are creating an exception class public std exception. Public, private, constant character pointer, and message. We will copy this constant character MSG bad shared PTR and message constant character pointer what constant noexcept override return this and message. So we created an exception class, bad shared PTR exception class like this using base. I will copy this. I say base T shared PTR. This is default constructor. In case of default constructor, this member is initialized to null PTR. Also, this member is null PTR. Shared PTR element type ELE PTR. This is base. Let's try this. If it works, element PTR, it requires two elements, two pointer element PTR and manage count PTR. Then here, new representation, it requires it requires element T and management. This is management count. We have to dynamically allocate management. So it is a size, use size weak count. Use size is 1. This is use size T 0. This is weak count. Okay. At this point, m element ptr is initialized to ele ptr, and m count ptr is allocated new manage count 1 0. Use this is weakest. I hope you understand this. M count ptr, m use count is set to 1, m count ptr, m weak count is set to 0. Don't forget explicit here. Okay, because this is a single element of type pointer, the constructor can be confused as conversion operator. In C++, constructors with a single parameter can be misused as a conversion operator. To prevent such misfortune, we need keyword explicit. Now we create Usecount size t Usecount constant. Please note that in default constructor, this member m count ptr can be null ptr. Also element pointer can be null ptr. So if base t m element ptr, then return base t m count ptr m use count, else return 0. Okay, now in this file let's test with a simple test. Shared ptr. We will copy this function, copy, paste, talk playpen, shared ptr int sp, talk playpen, shared ptr int sp1 new int. Now let's see if it builds successfully. Control F5. Sorry. Control F5. Okay, everything works. We will try Usecount, MEM, leak checkpoint, I say simple test, std, cout, sp, Usecount, sp, Usecount. Now I copy this, paste, sp1, Usecount, Ctrl F5. So sp Usecount is 0, sp1 Usecount is 1, memory leaked. Now here we create a destructor, shared ptr cleanup. In the private section, void cleanup. In case of default constructor, element ptr can be null. Okay, so we have to test if base t m element ptr is valid. We have to test m element ptr first. If it is valid, then we decrement m base t m count ptr m Usecount. We decrement like this. Okay, if base t, sorry, I will introduce another thing here. Using representation element type m count ptr using representation element type m element ptr. With this, we don't need base t. Now we don't need base t. I will simplify like this. Cut, paste, m count ptr m use count is 0, So if use count is 0, we delete m element ptr. Once again, if m count ptr m weak count equals to 0, delete m count ptr. Okay? Understanding this function is very important. Please note that when this memory mptr and this memory is managed separately, this means m count ptr m use count 0 and 0 then we pre m count ptr. Okay, understanding this point is important. Now in Constructor, clear. Now let's run it. Now no memory leak. Also in Weakptr, public, I copy this is Constructor. If m count it is valid, we decrement m count m weak count. Okay, we decrement if m count ptr m use count 0 and m count ptr m weak count 0 here m count delete m count ptr. Please note that we can delete m count ptr twice. Once here, once here. Okay, so we have to prevent multiple delete like this. Before we delete m count ptr m weak count, we set something weird number, size t -1. Okay, this is to prevent double delete. count ptr. In the same manner, I copy this here. This is a simple trick to prevent double delete. Okay? I will create a default constructor here, Weakptr. By default, m element ptr is null ptr, m count ptr is null ptr. Okay? Size t, use count. If m element ptr this is valid, then we can return m count ptr and use count. Else return 0. I don't think we need this. I will simply delete. I will delete this. Now I will create copy constructor here. One more. Weakptr is the shared ptr element type sp please, this is constructor representation. It requires 2 pointer element type sp m element ptr sp m count ptr. Okay. In this case, we have to increase weak pointer. Okay. M count ptr m weak ptr. Sorry, we have to check here if m element ptr is valid, then we can access like this weak count. Okay, this point is important because it can be null. Now let's see. I will create a function here. Copy. Weak count. Weak count. Okay, I will copy this once again. Copy. And I will also paste it here. I can simplify like this. Also, we can make it simpler. Now let's test. Here, talk play fun, Weakptr, int, wp. We are constructing this sp. std, cout, wp Usecount, wp Usecount, std, and I copy once again wp weak count. It is weak count. I copy once again wp1 sp1 wp1 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 wp1. So no memory should leak. Control F5. So it cannot find element, so I need using m element ptr m count ptr. I will copy this in Weakptr private. I pasted it here. Control F5. Okay, so no memory leaked. Let's examine. In case of Weakptr, because SP is not initialized default, use count is 0, weak count is 0. Because this is null, this is invalid. In case of WP1, this is valid. Use count is 1, weak count is 1. So it executed without memory leak. I will make some changes. Here, I will copy this, cut, and I will paste here, and I will change it to reset. Reset, and here at the end of this block I will change it to null ptr to make it not be called again. Okay, then I will copy this, copy, and I will make it like this. Save. Also in Weakptr, I will create void reset like this. Then I will copy this, cut, paste. At the end of this block, m element ptr null ptr. I modified like this, and I will call reset like this. Let's try once again. Ctrl F5. Okay, it works as before. Now we will add the lock function here. Shared ptr element type lock. Here please note that we are in Weakptr class. We have to increment if m element ptr m count m weak count. We increase weak count. Increase weak count. No. Use count. Use count. Then we return like this. M element ptr m count ptr. Okay. We are using copy Elison. Okay. To make it work, now let's try. It will not work. Auto sp2 wp1 lock. Let's compile it. We are calling this function Ctrl F5. No, it doesn't work, because here it doesn't work. To make it work, we need to introduce shared ptr element type ele ptr management count ptr representation, or we can say base T. Here ele ptr count ptr. Okay, so this constructor is for this lock. Okay, I say this constructor is for std weak ptr's lock member. Now let's try Ctrl F5. Now it works. We need to test another one here. Please note that here we have to increase use count. Okay, wp1 points to sp1. Okay, sp1, sp2, sp1, sp2, wp1, all points to the same object. So at this point, weak count should be std cout sp1's use count sp1 use count std, and there I will copy two more times. This is sp2, this is wp1, all should be 2. Okay, all should display number 2. Let's try. So the sp1 use count 2, sp2 use count 2, wp1 use count 2, so it's working properly. Now we are creating copy constructor. Share the ptr's copy constructor like this. Share the ptr constant share the ptr right hand side base t here, right hand side m element ptr, right hand side m count ptr. Okay, if m element count, we have to increase m count ptr use count, m use count. Okay, don't forget this. This is copy constructor. Now copy operator. Here operator, this is copy operator. If this is not equal to std address of right hand side, I will delete this part. Here we have to free this reset. Okay, free existing memory. Then m element ptr right hand side m element ptr m count ptr right hand side m count ptr. If m element ptr is valid, then m count ptr m use count. Okay, now we return this. This is copy constructor, copy assignment operator, copy assignment operator. This is copy constructor. Now we are creating move constructor. Share the ptr, share the ptr right hand side base t right hand side m element ptr, right hand side m count ptr. Now we reset right hand side. Reset right hand side. Okay? No, this is wrong. Don't do this. We have to do right hand side m element null ptr. This is good enough. Okay? This is good enough. And move assignment shared ptr. I have to change like this. Also, in case of this is move constructor, it does not throw exceptions, so noexcept. Operator shared ptr right hand side if this not equal to std address of right hand side m element ptr right hand side m element ptr m count ptr right hand side m count ptr and right hand side m element ptr null ptr. Okay, this point is important because this is move assignment operator. Move assignment operator, we have to return this. Okay, this is move constructor, and in case of copy assignment operator, we have to increase use count. Okay, and don't forget resetting our previous memory. This is constructor, copy constructor. Okay, we also have to increase use count. We have to make another changes. In case of this is move assignment, we have to delete existing memory. This reset. Okay. In case of move assignment and copy assignment, we have to pre-existing memory. Okay. And in case of copy assignment, we have to increase use count, and also copy constructor, we have to increase use count. I will factor out this part, copy, and in private section void increment use count. I paste it like this. Then I will copy this function, copy. Then I will modify like this. Copy once again, copy. And I will modify like this. Also, okay. I will copy this function once again. Copy. In Weakptr in private section, I will copy this. And no, this is Weakptr count. I can change it here. Copy. Okay, I modified like this. Now let's test with constructor. I will copy this part, paste it here, test shared PTR constructors. I will copy this function name, copy, paste, and disable it. Talk play fun, share the PTR, int, sp1, new int 1. Now let's test the copy constructor, auto, sp2, sp1. We are testing copy constructor, std, cout, Usecount, sp1, Usecount, std, and there I say sp1. I will copy once again, sp2, Usecount. Both should display 2. Okay, both should display 2 because we copied here. Ctrl F5. Okay, both displays 2. So copy constructor works properly. Now we use move constructor like this. Auto, sp3, std, move, sp2. Okay. Now I copy this, sp1, sp3. Okay. I say sp2. It should display 0. Okay, because we moved. sp3, use count should be 2. It should display 2. 2, it should display 0 because we moved. Ctrl F5. Okay, 2, 0, 2. Move constructor works properly. Now copy constructor. Talk play fun. Shared PTR, int, sp4. We are testing with copy assignment, sp4, sp3. This is for copy assignment. And let's test. Paste. sp1, sp3, sp4. Now it should display value 3. Okay, Ctrl F5. We are testing copy assignment, so 3. sp1, sp3, sp4 all points to the same elements. So copy constructor works. Now move assignment. Move assignment. I will copy this. This is 5. Move assignment sp5, std. Move sp4. We are testing move assignment. Now I copy this. pasted it here, and copy, paste. This is 5. I will put some title, std, cout. This is copy constructor. Test copy constructor. std, and there I will copy this. Test move constructor. And this is copy assignment. Test copy assignment. This is move assignment. Control F5. So test move assignment 4 is 0. The values are the same. So everything seems to be working without resource leak. Now let's define some operators. I will define operator here at this level before copy constructor. Operator bool constant return this m element ptr null ptr, and I will define one more element type reference operator. This is the reference operator. Return m element ptr like this. You should be careful here. If m element ptr, then we can return like this. Else throw bad shared ptr invalid element pointer. So when element ptr is null, then we throw exception like this. Shared ptr. This exception message. Now here element type, we are returning pointer operator. If m element ptr, return m element ptr. Else copy paste. Okay, but we need more advanced technique here. Template type name type std enable if t std is same b type element type, and std is class b type. Then we are returning element pointer. This might look a little bit complex. I will explain one by one. First, we have to break tie between operator, function, and shared ptr element type class. So we have to introduce new template parameter for this member operator. Second, template parameter type should be the same to element type. So we test std is the same b type element type. Also, element type should be of class type. Otherwise, operator is meaningless. So we test std is class B type. If all these conditions are met, then we enable operator overloading. Otherwise, this operator is not defined. Okay? I explained about all these things in my previous videos. I explained about all these concepts through my previous videos, especially template metaprogramming and type function. These series of videos, I explained these concepts. It might be a little bit complex for you. I also use spinning feature. So I defined three new operators. This is Boolean operator. This is dereference operator. And this is pointer operator. For our convenience, I will set default argument, template argument like this. Element type. Okay. Now let's test these new operators. Void test shared ptr operators. Memlink check test operators. I will copy this function, copy, paste, disable, std, no, talk breakpoint, shared ptr, int, sp1, new, int, 0. I will copy another one. This is 2. If sp1 std cout sp1 is valid, std and else std cout sp1 is invalid, std and there. Now I will copy this one again, copy, paste, this should be 2, 2, 2. We are testing this operator. Okay, I will modify it noexcept because it does not throw exception in this case. I will copy this. We are testing shared PTR operator. Okay, I hope you understand. Now we run Ctrl F5. So in case of SP1, we haven't initialized, so SP1 is invalid. In case of SP2, we initialized, so SP2 is valid. So this operator works properly. Now we test this operator. std cout the value of sp1, this is 2, equals sp2 std enter. Okay, we are testing this operator now. Copy. Shared PTR. We are testing this operator. Now let's run Ctrl F5. Now it works properly. We can increase the value like this. sp2 we can increase. Okay, then paste it here. The value of sp2 after increment. Ctrl F5. So this operator works properly. Now about this operator, we are testing this operator. So sp2, it does not compile. It should not compile, okay? Because sp2's element is int. Int does not have such operator. Okay, so it filters out. Instead of doing this, we will create a class. Here, struct obj class. I create a simple struct int member. I will just initialize 0. Now we test this. Void test. What do we call this operator name? I say arrow operator. Member access operator. Access operator. Okay. Talk play fun. Shared PTR obj class sp new obj class. I will copy this function. Let's build. If it compiles, Ctrl F5. Okay, it works. Then we can access like this. sp member 5 std cout sp member sp member std enter. Okay, now let's try Ctrl F5. Okay, it works successfully. So this operator we are testing shared PTR operator. Okay, so we defined a few member functions of shared PTR and Weakptr. I think this part of code is a little bit difficult for most people to understand. To understand this concept, you should first know and understand immediate context. Please watch this video. In this video, I explained what is immediate context. Without understanding immediate context, you cannot understand what is spinning, what type functions, etc. Also, you need to understand the class template parameter type deduction guide. Okay? Break tie. You need to understand the concept of breaking tie. In this video, I explain breaking tie between enclosing class and member function, especially member template. By watching this video, please try to understand what does it mean breaking tie. Also, you have to understand member templates by watching this video, how to create member templates, member template functions. And also, you need to understand spinning and type functions by clicking this link. You need to understand the spinning and type functions by watching this video. In this video, I also explained how to use enable if t. So, these are all references I copied and I will paste it for your reference. Like this. These are for your reference. So this is a very small short function, but to understand it, it requires quite a lot of knowledge. If I add all bells and whistles of shared PTR and Weakptr, I may need a few more hours, probably several more hours, but my primary intention of this episode is how to implement shared PTR such that you can use shared PTR correctly. Okay, I don't mean to create a complete shared PTR for you. Instead, I just wanted to show you, help you understand what shared PTR means. In future sessions, I will explain how to use shared PTR properly and its strong points and weak points and how we should use shared PTR properly. As you may have noticed, shared PTR is very inefficient because it manages internally separate two memory pointer. So creating small elements for shared PTR is bad idea. And this is not for trivial application, but when your program becomes very complex, shared PTR can be very useful. In future sessions, I will explain how to take advantage of shared PTR and Weakptr for multithreading. Please subscribe to my YouTube channel. Thank you for watching.